In this series of videos I'm attempting to repair and restore an Osborne OCC1 vintage computer. In the first video in this series I dismantled the unit into its major sub-assemblies, and we had a quick look at them, and they're really in need of good cleanup. I don't know how well they work. The machine was sold on eBay as not working, and it was shown with just garbage on the screen. When I booted it up I did get the startup screen, but then it started misbehaving and doing strange things, which I believe is a fault in the power supply, but there could be other faults as well of course. Getting this unit apart is relatively straightforward, just a handful of screws, and it then all comes apart relatively easily. The first thing I'm going to look at is the chassis. So this is the main chassis for the unit. It's in reasonable condition, it's not too bad. It's got a few scuffs here and there, but it has got some parts broken off that need to be refitted. So I'll get those bonded back in place, get it cleaned up, and the next time you see this it will be ready to start refitting all the parts. I won't go into the detail of what I'm doing with this. It is just a clean and gluing a few parts back to where they dropped out. There are no major cracks, no major breaks, which is a good thing, and as I said, this should be a fairly easy part to repair. We shall now go on to the next item in the list, and that is the power supply. So this is the power supply out of the unit. It's fairly straightforward. It's just a triple rail output supply, and you can see up here it's got the voltage outputs that are expected. So it's minus 12 volts, plus 12 volts, and plus 5 volts. And this is what I believe the first faults are that we need to address. Firstly, we have the usual collection of failed reefer caps, so I will replace those. We've got what appear to be some dried joints. I've had a look at this fairly carefully, and there are some cracks around some of the joints, so I'll resolder the ones that appear to be not making good contact. And a couple of the caps have also decided to start pushing out their contents. So I should probably replace all the large caps on this. I don't normally shotgun electrolytic caps on a unit that's as new as this. I say new, it's relative of course. But in this case, because some are showing signs of fatigue, I will replace all the major caps. There's not much else on here, so hopefully by the time I've done that, this will be a fully functional supply. But what we'll do, because as I've said in previous videos, if we plug a faulty supply into a vintage computer, it's only a matter of time before some serious damage occurs on the board. So I want to get this sorted out properly first, so we'll attach it to some electronic loads once I've replaced the caps, and we'll make sure that it's behaving itself and isn't going to cause us any further problems. So I'll get the parts changed that I need to, get the loads set up, and then we'll see how well it performs. I'm in the process of replacing the caps on the board. I've already replaced the X and the Y caps, and the usual has occurred, so that's those sorted out, and I'm now replacing the electrolytics. Luckily I do have some pretty much exact replacements. They're not identical, but they are very close, so it should look fairly similar when I finished. The X and Y caps do look different. They're blue and grey rather than the gold reefer colour, but that's unavoidable. I don't want to refit the reefer caps. You can still get them as new old stock, but don't ever refit those. So we should end up with something fairly similar. I've been testing these caps as I've taken them out, and only two have shown us faulty, and the rest are reading okay, but I'm going to replace them anyway. And the way I'm testing them is I do have a capacitor meter, and I've tested them on there, and they're showing as leaky, and also I've connected them to the bench supply, and again they are drawing a current. They're not getting particularly hot, but it's only a matter of time before they fail. One was normally, once they've charged up, the current draw should be almost zero, just a few microamps. but one's drawing about 7 milliamps and the other's drawing about 3 milliamps, so they are on the way out. I've just got 2 more to pull out of the board, and then I can start replacing them. I'm refitting the replacement capacitors, and one of the 2 larger capacitors on the input side had a warning label on it, so I'm going to transfer that onto the new capacitor. It's as well to transfer warning labels like this. In theory no one's going to see it again, but you never know, somebody might open this up, touch the heatsink and be none the wiser. So I'm going to swap this onto the capacitor. Chances are no one would read it even if they did tear this apart, but at least I've done my part in trying to protect them. I finished replacing all the capacitors. I've cleaned all the excess flux off the underside of the board, found a few dry joints which I've resoldered. I did transfer the warning label onto the new capacitors, and what I can do now is run it up and see if it actually works. It was kind of working before. The machine would power up, but it was doing some very strange things, so I suspect it wasn't behaving the way it should do. But at least now we can power it up without hopefully the danger of the reefer caps exploding. So the way I've got this set up is, or the way this power supply works, is there are 3 output connectors on it, but they're all the same. They have a common, there are 4 pins on each. They have common +5, +12 and -12. Now the -12 volt rail is not actually used on this machine, but we'll test it anyway. On the grounds that if it's misbehaving, then that can upset the supply. The feedback for the +5 and +12 volts is kind of common, so if one's working, chances are the other should be working. There can be exceptions if there are bad diodes or something like that, or if there's a faulty cap, but we'll power it up now, see what it does. I've got the bench auto transformer set to around 200 volts. I will wind it all the way up to 250 once I'm happy this is working. It is configured for 230 volt operation. The wiring loom is a bit misleading on this machine. There is a jumper here for 115 volt operation, and the way the input to this works is it acts as a voltage doubler when it's wired for 115 volts, or straight through when it's wired as 230 volts. So although there is a pin here that says 230 volts and it goes back to the voltage selector, it doesn't do anything when it's on 240 volts, so it will work fine as it is. We don't need this connected and we don't need this connected. So I'll get it powered up. Hopefully there won't be any magic smoke escaping. I will also turn off one of the lab lights, and it will hopefully cut down the annoying flicker that you're seeing on the Cumkin electronic loads. So I'll turn that one off. Hopefully you can still see enough. What we'll do now is power this up. This load is not connected to anything. This one's connected to +5 volts. This one's connected to +12 volts. So we'll get this powered up. Okay, good first sign. We're getting close to 12 volts and close to 5 volts. These supplies are a bit strange, and I have mentioned this before, that they do need a minimal load, otherwise they can misbehave, and they can even trigger the crowbar protection on the output. It shouldn't do any damage, but it will shut down the supply, and it may appear that it's not working until it's power cycled. I've got everything referenced to 0 volts, so what we should have on these connectors is -12 volts at the top, which we are getting. I'm hoping you can see the multimeter. So it's -12, and next pin down, +12, and we have common, and then +5 at the bottom, which is all looking good. The loads, or the voltages shown on the loads, will be a bit out because I've got everything going through a common connection, whereas the actual machine uses separate ground connections for the 2 rails. So all 3 rails are working. We're drawing 0.5 amp on the 5 volt load, 0.3 amps on the +12 volt load, which is the minimum specified. We'll turn up the mains supply, so up around 240 volts. And what I'm going to do now is increase the current on the two rails up to about 70% of the maximum permitted, and then we'll power it back up and leave it running for a while. I'm going to turn off the power, make the adjustments. Okay, now we can turn this back on. And it's looking fine. So what I'm going to do now, I'm going to leave this running for about 6 hours and make sure nothing fails. On the assumption that there aren't any issues, I'll get on with the rest of the modules for the machine. In the meantime, I'm going to get the chassis over to the workshop and get it cleaned. The supply's now been running for about 6 hours and nothing's failed. The voltages are still correct. I actually set the 5 volt rail current to 2 amps and the 12 volt rail to 1 amp. And it's getting a little bit warm, but it's quite an efficient supply, so it's not really getting particularly hot. The voltage looks a bit low on the Kunkin, but that's the drop in the leads. The wires are fairly thin that come out of the supply. It doesn't normally supply all that much current. If we actually look at the voltage directly on the board, then as you can see it's around 4.98 volts, so very close to 5 volts. And the same with the 12 volt rail, that's also quite close to 12, much more so than the Kunkin would tend to have you believe. I could of course put remote sensing on, but I'm not really interested here in accurate sensing. I'm just trying to do a soak test and make sure it's going to be reliable and that nothing pops. So that's probably long enough to test this. I might leave it on test for a while longer yet once I've got it bolted back into the chassis, but it's certainly looking like it's going to survive. And I have briefly run it up to full load, so that was 5 amps without the 12 volt rail running and it was fine, and then 2 amps on the 12 volts and 3 amps on the 5 volts, and it sagged a little, the voltage sagged a little bit, but nothing failed, and it seems to be working fine. Efficiency good. We're at 240 volts input, it's drawing about 150 milliamps, and we're outputting just over 20 watts, so it's quite efficient. It's not doing too bad at all. And so that's it for this part of the test. The next thing I want to do is get this bolted back into the chassis. I have cleaned the chassis and I've glued on the bits that had snapped off, so that's come up fairly nice and clean, and is now ready to start reassembly. So I'll get the power supply out of the way and we can start looking at the monitor. For anyone interested, I've been monitoring this using the thermal camera and nothing's getting excessively hot. 55 degrees, 60 degrees is the hottest components I can find, which isn't bad at all. The camera does of course automatically scale everything, so it looks like certain components are cold, but they're not. They're simply not as hot as others. The tops of the caps look cold, but that's because they're reflective. They're not actually that cold. But the hottest cap of the larger caps is only about 36-37 degrees, so that's quite reasonable. And the active components and the main chopping transistor is actually quite cool. That's only up about 43-44 degrees centigrade. Now this is of course open. It would normally run a lot hotter than this when it's in the cabinet, and there is no fan on the cabinet. But even so, running this cool out on the bench, and I've purposefully left the extractors turned off so there's no real airflow around this. So I'm not expecting this to cause any problems, and it's now ready to refit into the chassis. So we'll get this refitted and then we can move on to the next item on the list. That's the power supply fitted back into the chassis, and it should work fine. It was running for quite a long time, didn't have any issues. I ran it again once I bolted it back in just to make sure, and it seems to be working fine. So we can now start moving on to the other items, and as we work our way through them we'll refit them to the chassis. So next thing to get onto the bench is the monitor. So the next thing on the list is the CRT monitor. We know this works. We already ran this up and we had a good display, or at least a reasonable display. It was a bit distorted, but I think that may have been the power supply. There are a couple of suspect caps on this board, or the board on this, so I will replace those, but mostly this is just giving this a quick clean, so we'll do this the easy way. Okay, well that's the monitor assembly fitted back into the chassis. It did clean up very nicely. There's no real sign of damage on this. I cleaned all the rust out of the enclosure and bolted it back in. So that's the monitor assembly ready to go. We know this worked anyway. Just a couple of replacement caps. They seemed alright, but I replaced them just as a precaution. We could of course run this up outside of the machine if we wanted to using signal generators, but as we know this works anyway, there's no real value in doing that. So we can move on to the next item on the list, and we'll save that for the next video, and of course the next item will be the disk drives.